Hi, everyone. Thanks so much for joining us today. My name is Keegan Marazi, and I'm a Partner Solutions Architect here at AWS. Today, we're joined here with Jeff.
Hi, everybody. I'm Jeff Bloom. I'm the founding Principal Solutions Architect at WIV.
So let's talk about something every FinOps team deals with. Someone asks a question about cloud costs, and one query is usually never enough. You always end up going down a rabbit hole of different services and different APIs.
Exactly. This is the pattern that most teams run into. Someone asks, well, what spiked this week? And you'll get an answer. But that immediately leads to the next question. Well, which service drove it? And then, which team owns it? And then, is this a recurring pattern? And finally, well, what do we actually want to do about it? By the time you reach a meaningful conclusion, you're actually 5 to 10 queries in. And a senior analyst would do this instinctively. They know what to ask next based on what they just learned. The challenge is turning that into a repeatable system. And that's exactly what our orchestrator is built to do. Most teams tell us that a manual investigation like this takes anywhere from 30 minutes to 2 hours.
Wow, that's a pretty significant range of time. Can we go into a little bit of how WIV approaches this problem?
Absolutely. Let me show you by walking through the orchestration engine architecture. There's 4 stages in the loop. First, the router LLM is interpreting the request and plans the initial AWS queries with up to 5 steps in parallel. Second, those steps execute concurrently across services like Cost Explorer, Athena, and CloudWatch. Third, the orchestrator LLM reviews the combined results and decides whether it has enough to answer the question or does it need to dig deeper. And fourth, it loops. That can happen up to 4 iterations, so a single investigation can drive more than 20 API calls, each one informed by the previous round. Now that's especially powerful in multi-account environments, where the system may need to aggregate data across accounts, reconcile inconsistent tags, and work through different IAM configurations automatically.
You can really tell that we're moving away from an if this, then that generative AI chatbot into an AI manager that can dig deeper across multiple accounts. This is a greater example of how agentic AI trends are moving and changing how organizations and enterprises are utilizing AI to advance and increase efficiency across their AWS accounts and products. It's a great example of how Amazon Bedrock helps simplify this multi-step process into a unified user interface. Now, let's talk a little bit about concurrency and why does parallel execution matter in this iterative orchestration?
Well, let me show you the difference between a sequential approach and the parallel approach. So in a sequential approach, you would query Cost Explorer, you'd wait for that response, and then Athena, and then wait for that response. CloudWatch, wait for that response, and then whatever other service you have going on in the investigation. Each call carries its own network and processing overhead, so when you chain them together, a single round can easily stretch around 15 seconds. With WIVI, those calls are all dispatched in parallel, which brings that same round down to about 3 to 5 seconds because you're only waiting for the slowest response. Those results are then merged and passed to the orchestrator, LLM, which then decides if it has enough context to answer your question or if it needs to launch another round and to keep digging.
You know, that's a massive efficiency gain, and it highlights another pillar of the AWS well-architected framework, which is operational excellence. So moving towards parallel workflows that make your operations faster and more reliable with less overall overhead and an increase efficiency to your execution management.
Absolutely. At this point, a natural question might be, well, what's different between using WIVI and just using a chatbot with an API plugin? Let's walk through the comparison row by row. On depth, a chatbot is going to give you a single response. Well, with WIVI, you're going to get a full multi-step investigation. On memory, our orchestrator is preserving that context across steps, so each result is shaping the next decision. On control, the user does not have to keep steering the process. Our agent keeps deciding what to query next. For insight, WIVI does more than just identify a spike. It can automatically drill into the underlying cause. And for scale, a single investigation can involve up to 20 API calls working together toward a conclusion.
So in the comparison, I can tell many differences in how each solution gets to a final answer. But kind of going back to our original question, if I ask both of these bots, why did my Lambda cost spike? What should I expect as the difference in outputs between the two?
It's a good question. A chatbot gives you one response based on the data it has. It might tell you EC2 costs increased by 30%. But then you still have to ask the follow-up questions yourself. What accounts? What team? What changed? With Wivy, one question triggers the entire chain automatically. It finds the spike, identifies the service, drills into the account, drills into the team, checks utilization, and returns a root cause with an actual recommendation of what to do next.
One thing I'm curious about is when you're querying 4 or multiple AWS services in parallel, you're going to get a lot of results in that context window. So how do you handle that with LLM context windows and dealing with the increased context at an increased price?
That's actually one of the biggest engineering challenges that we had to solve. When raw API responses are too large, we actually run a secondary LLM pass to summarize each chunk before it goes to the orchestrator. So it knows what needs to be summarized and what must be preserved. Dollar amounts have to stay exact, resource IDs remain intact, anomalies and cost spikes are still flagged, and time series patterns are retained. Basically, we're compressing the noise while keeping the signal. That allows the orchestrator to stay within the context window without losing what matters for the next decision. And we validated this pretty heavily before shipping it. We compared full context answers against summarized context answers across hundreds of real investigation scenarios. And the accuracy difference was under 1%, while the latency improvement was also significant.
You know, that's a really great observation, and I think it highlights how LLM context is a factor that developers should always consider when developing generative AI applications, especially from the lens of cost optimization, which is accomplishing the same task with fewer context tokens, and how that should always be viewed as a win, even if efficiency doesn't really change significantly.
Let's make this concrete. Let's show a real investigation. If a user asks, why did our cost spike this week? The orchestrator is going to work through that in 4 iterations. First, it looks in Cost Explorer, and it sees that EC2 spend is up 40% week over week. That tells us what changed, but not the root cause. Next, we're going to drill into the cost allocation tags, and we find that the data pipeline team owns 80% of the increase. Then, it's going to check CloudWatch, and it finds 12 M5 4XL instances sitting below 10% CPU utilization. And finally, it synthesizes those results into a root cause analysis and a recommendation to right-size those instances to M5 extra larges, with an estimated 60% savings on the cluster. That's iterative orchestration in action. The system reasons through the problem the way an analyst would, but in seconds instead of hours. And that ties directly back to our previous video. The orchestrator is really the brain here deciding what to investigate, and that multi-integration engine from the first video is the hands executing the queries.
Wow, that's super impressive. Thanks for walking this through with us.
Well, thank you for having me. If you'd like to explore Wiv further, take a look at the links in the video description, and you can also find us on the AWS Marketplace.